Hi, my name is Cameron Akbarzadeh, and this is Live 5, The Slinky. I first would like to apologize for my lack of a voice. I'm currently pretty sick right now. However, let's go forward with this lab. The objective of the lab was to find out what happens when a slinky that has been extended under its own weight is released, and how it falls to the ground. Does the bottom or top end fall first, and does it collapse together and then fall? I found out this result by using VPython to show the motion of the slinky as it fell, and found that the top end falls first while the bottom end stays up. First, let's watch the video in normal speed. As you can see, you can't really tell obviously, the slinky just fell. Now, let's watch it as the code shows. As you just saw, the slinky settles itself on its sides at the very beginning and starts to compress from the top until it hits the bottom of the slinky. Now let's go on to the reasoning behind why this is occurring. Firstly, in the code, I told the code to print out the center of mass. And this is because the center of mass is very important in this. The center of mass was the vector of 0 and negative 0.0851866. This vector means that the center of mass was towards the bottom of the slinky and not the center, because when the top of the slinky starts to compress, the density of the slinky at the top is greater than the bottom. Also, it shows that the center of the mass is towards the bottom of the slinky, and everything at the top would compress. Another reason for this nugget of physics is that at the bottom of the slinky, the tension force, which is the up arrow, and the gravity force, which is the down arrow, are equal and opposite forces. Thus, when the slinky comes down, so is the tension force, until it compresses fully and travels down, since it's being pulled by gravity. Now, what if there was a mass on the bottom of the slinky? Would the top end still fall first? Yes, it will, because the weight force acting on the mass depends on the upwards tension force until the slinky starts to propagate down and compress fully, where the weight force would just pull it down faster. So the only difference is that the speed of the motion is faster. Thank you for watching, and again, I apologize for my voice.